Hi, this is a supplementary math lesson for Algebra 1, lesson 118, the slope formula. So what we're going to be doing, we're going to be determining the slope of a line given 2 points, and I'm going to be working off example 118.1 on page 433 in your textbooks if you want to turn there. Okay. The problem is find the slope of a line that goes through these 2 points. They list -3, 4, and 5, -2. Okay, so what we have done so far is we would go to our graph. Okay, we would plot -3, 4, put our dot there. We would plot 5, -2. We would draw our line in. We would determine the slope of the line between those 2 known points exactly. Okay, the slope being m in our equation, y equals mx plus b. Now notice, they're just asking for the slope in this example, and I notice they do the same thing in your homework. They're not asking for the equation of a line. Okay, they just want to know the slope. What is our slope? Our slope is defined as the rise over the run. And I said we read from left to right. So we go to our leftmost point. What does our rise do? It goes down 6 units, -6 units. What does our run do? It goes over to the right, +8 units. Our run is always positive to the right. Okay, we bring that sign out in front. We have a 6/8. We reduce it to -3/4. Okay. So that is the procedure that we've done so far. This is our answer. This is our slope. Now, they say we don't even have to go to the graph with this anymore. If we know the 2 points, we can simply use the slope formula at the top of page 433. Okay? They have that indicated as m equals y2 minus y1 over x2 minus x1. Okay, what is this saying? Okay, this is the same thing that we have here, the rise over the run. What we're going to do, we're going to label one of these points as point 2 and one of these as point 1. Okay, and then we're going to simply plug in the y coordinate for point 2 minus the y coordinate for point 1. The same thing with the x coordinates. We're going to plug those in. Okay, but I just want to back up. What are we actually doing? We are doing the same thing. This is nothing more than a re-expression of our rise over our run. What is our rise over our run? It's the change in y. Remember that delta symbol represented the change in the y coordinate over the change in the x coordinate. Okay, back to our line. Okay, what we've done, we've drawn this line. Okay, but we've selected these 2 points here that they gave us to determine over that range of the line between those 2 points, what is the change in the y? Well, the change in the y is it goes down 6 units. I've been simply counting them. 1, 2, 3, 4, 5, 6 to this point here. And what is the change in the x? I count over 1, 2, 3, 4, 5, 6, 7, 8 units gets me to that point. It's nothing more than the change in the y over the change in the x. Okay? Now, let's use this slope formula they've given us, and let's use this point over here from left to right as point number 1, and this one as point number 2. Okay, so what is my y coordinate for point 1? And let's put these up here. This is my x, this is my y. My y coordinate for point number 2 is -2. Now this, you got to keep track of your plus and minus signs here. And I'm going to subtract my y coordinate for point 1. Y coordinate, point 1, is +4. You can even put that in there. Okay? And then what is my x coordinate for point 2? It is 5 minus, what is my x coordinate for point 1? It is -3. okay? Then I go ahead and combine those. I have a 2, these signs combine to be a negative. I have a minus 6 on top of minus 2, minus 4 is a minus 6. Okay, what do these signs combine to? A minus times a minus, they combine to a negative, or excuse me, a positive. Okay, 5 plus 3 is 8. Okay, I move that negative sign out front. I have minus 6/8. I reduce my fraction to minus 3/4. Voila, I've gotten the same result, okay? And what am I doing here? I'm doing nothing more, okay, than doing, when I do that on the triangle, and what I'm doing here in the equational form, I'm basically doing the same thing. Well, I'm not basically doing, I'm doing exactly the same thing, okay? This, I'm doing it inside of an equation, okay? That, I'm doing it graphically, but I'm doing the same thing, okay? Now, the interesting point with this slope formula, if you're wondering, like, well, gee, which point do I pick for point 2 and which one do I pick for point 1? Because I read from left to right. Okay, if you can recognize that minus 3, the x is furthest left. Okay, that way I can read from left to right. But if you pick the wrong way, don't worry. In the slope formula, it's got you covered. Let's do this the opposite. Let's pick this top point as point number 2, and this one here is point number 1. And that's the next example, 118.2 on that page. Okay, they said, let's go ahead and do that. Let's figure that out. M is going to equal our slope formula. Okay, let's plug in the points. This is 2. Okay, now point 2 is on top. What is the y coordinate for point 2? It is 4. Minus, what is the y coordinate for point 1? It is a minus 2. What is the x coordinate for point 2? It is minus 3. And I'm going to subtract the x coordinate for point 1 now, which is 5. Let's see if I have signs to combine. I do up here. This becomes positive. What do I have? I have a positive 6. I have a minus 8. I bring that sign out front of the fraction now. 6/8. I reduce the fraction to 3/4. Voila! Same as the one above it. Same as our slope in the graphical method. It doesn't matter which point you pick as point 1 or 2. What matters is you pick the correct coordinates for those points and plug them into the right spot on the equation, and you're always subtracting. And you got to keep track of your positive or negative signs on your points, okay? So that way we can use this slope formula. We don't have to go to a graph and do this, and that will be helpful if they give us points that are like, 108, 67, minus 43, 18. Okay, we don't want a huge graph, and we don't want to have to devise a graphical solution for that. We can just simply plug those points into our slope formula. And notice what it's doing, why it doesn't matter which point we use, because when we took the furthest left point for point 1, this one for point 1, and this one for point 2, what did it come out? We had the negative ending up in the numerator and a positive in the denominator. When we switched it around, okay, when we used this as point 2 and this as point 1, what had happened down here? It gave us a positive in the numerator and a negative in the denominator. Now, we say when we do that graphically, that's a no-no. We don't do that. Well, the formula doesn't know about that reading from left to right, okay? And it actually corrects itself, as long as you keep to the convention, plugging in the right coordinates and keeping the signs, okay? It will correct itself in this way, because it will have when we do it the first way, we had a minus in the numerator, a positive in the denominator. When we did it the opposite way, we had the positive and negative then swap numerator and denominator, but it all comes out to the same answer. Okay, so don't fret over picking the right point. Fret over picking the right coordinates and keeping the right minus and negative signs when you do that. Okay, so I hope that helps. Shoot an email or a text message with any questions. So long for now.